Could the Earth's own rotation be a hidden source of electricity? A team of physicists has uncovered experimental evidence suggesting that rotational energy from the planet itself can be converted into electrical power. Unlike solar or wind energy, this approach doesn't rely on changing environmental conditions, but instead taps into a fundamental and constant planetary force. For decades, scientists have debated whether Earth's motion through its own magnetic field could generate usable electricity. Theoretical models suggest that this rotation should induce an electromotive force, but previous experiments have failed to produce a sustainable current. Conventional physics dictates that any voltage generated would self-cancel as electrons realign, making the energy unusable. 3 researchers, Christopher Chiba from Princeton University, Kevin Hand from NASA's Jet Propulsion Laboratory, and Thomas Chiba from Spectral Sensor Solutions, set out to challenge this assumption. They suspected that past failures were not due to flawed theory, but rather to limitations in experimental design. Their goal was to isolate the mechanism responsible for this elusive energy and eliminate interfering variables. To test their hypothesis, they constructed a custom device using a cylinder of manganese zinc ferrite, a weakly conducting material with strong magnetic shielding properties. Positioned along a north-south axis and tilted at a precise 57-degree angle, perpendicular to both Earth's rotation and its magnetic field, the device was designed to detect any potential voltage generated by the planet's movement. Electrodes at either end of the cylinder recorded a consistent voltage of 18 microvolts, a result the researchers attribute to Earth's rotation through its own magnetic field. The team knew that such a claim would face intense scrutiny, so they conducted extensive control tests to rule out alternative explanations. Potential sources of interference, such as thermal gradients, were carefully measured and eliminated. When non-magnetic materials were used in place of ferrite, or when the cylinder's orientation was changed, the voltage disappeared. This reinforced the idea that the observed effect was real and not an artifact of external influences. Although 18 microvolts is an extremely small amount of power, the significance of this experiment lies in proving that such energy conversion is possible. The researchers emphasize that further studies are needed to replicate the results under different conditions and explore whether the effect can be scaled up for practical use. If this principle holds, the implications could be revolutionary. Unlike solar and wind energy, which fluctuate based on weather and time of day, Earth's rotation is a stable and perpetual force. In theory, this makes it one of the most reliable potential energy sources. While the technology is far from commercial application, future advancements in materials and device configurations could enhance the output significantly. Beyond Earth, this discovery could have profound implications for deep space exploration and off-grid scientific missions. In environments where conventional power sources are impractical, a device harnessing rotational energy from celestial bodies could provide a reliable source of electricity. Though the journey from microvolts to megawatts is long, this experiment opens an exciting new frontier in renewable energy research.